Hello and welcome to this video. Today we're taking a look at rendering eyeballs in Cocos Creator. We will be using several different textures to render the eyeball. One for the iris, one for the sclera, and one for the reflection on the eyeball. This will allow us to dynamically change the size of the iris and the size of the pupil, as well as the color of the iris. The mesh we're going to use for the eyeball is very simple. It is basically a primitive sphere with a small bump at the front where the cornea should be. The UV for the mesh is very simple as well. All we did is a front projection of the sphere. Now there will be some distortion at the sides of the sphere because of the UV, but this shouldn't be a problem because we barely get the chance to see the sides of the eyeball. Now, taking reference from the physical structure of the eyeball, there's a couple of features that we need to pay attention to. First, we can see in this diagram that the eyeball is not a perfect sphere. There's a small bump at the front, and we already created this in the model. Behind the bump is where the iris should be, and the pupil is the hole in the middle of the iris. So we need to be able to shade the iris in such a way that it looks like it is inside the eyeball and behind the bump in the front instead of floating on top of the bump. Our first task is to mix the texture for the iris and the sclera so that we have a fully textured eyeball. Before we are able to blend the textures, the first thing we need to do is to be able to move and scale textures as we do in content creators such as Photoshop. We can scale and offset textures by performing basic arithmetic calculations on the UVs for the texture. By multiplying the UV by a particular float number, we are effectively scaling the texture by that number. And by adding or subtracting the UV by a vector 2 number, we are effectively moving the texture on its x and y axis. You'll notice that when we try to move and scale the textures by modifying the UV, the texture gets tiled. Namely, the texture tries to repeat itself so that it can fill the entirety of the UV space. This behavior is controlled by the wrap mode settings for the texture, and we can directly get access to them in the Properties panel by selecting a texture in Cocos Creator. If we don't want any tiling to happen and we have only one instance of this texture on the material, we need to switch wrap mode S and T from repeat to clamp to edge. Another issue you probably noticed is that when the texture is scaled and moved, it is using the upper left corner as the anchor point. It would be more ideal if we could scale and move the texture using the center of the texture as the anchor point. To do this, we need to first move the texture to the upper right corner first, that is by 50% in both the X and Y axis. Scale the texture as we intend it to be, and then move it back to its original place. Now that we have placed the anchor point for the iris texture in its center, we can use a custom parameter to control its size as intended. Next, we need to be able to push the iris texture into the mesh so it looks like the iris is behind the cornea. This can be done with parallax mapping. Parallax mapping is the technique that uses very simple mesh to render complex geometric structures such as bumps and dents. A very similar technique is normal mapping, but the major difference between the two is that normal mapping utilizes vertex position data from normal texture maps rather than from the mesh itself to do shading calculations. The render results will show all the details as if it is rendered from a much more complex mesh, but the mesh actually remains the same. All the bumps and dents in the details are actually fake, and there are no actual bumps and dents on the mesh. Parallax mapping works in a different way. Instead of data from a texture, we use the actual vertex data that we extracted from the mesh. But we modify the vertex data a little bit so that it performs differently than the regular mesh as we import it. In this diagram, the gray surface is the actual surface of the mesh. This could be a simple plane, a primitive sphere, or any other low poly mesh. The red lines indicates the intricate surface we want the simple mesh to look like. When we observe this object, we should be looking at point A in the actual mesh. But if we pretend we're not looking at this simple surface and instead we're looking at the intricate surface, we should be looking at point B instead. So the question is, how are we going to produce the visual outcome of point B by using only data from point A? Now, just by looking at this diagram, it looks like we can basically move from point A in the reverse direction of the observation vector by a certain extent, and it should be able to bring us closer to point B. So basically, we want to know how far do we move from point A in the direction that is the reverse of the observation vector. We talked about vertex normal, vertex tangent, and bitangent in a previous video, and we know that we can use a scale value in the vertex normal direction to indicate how far the surface bumps out or dents in. This is basically how height maps or bump maps work. We use a grayscale map, which is basically a bunch of float numbers to indicate the scale in vertex normal direction. In other words, if we have a height map, we'll be able to know where point A should be if it is an intricate surface, which is point A's z position in tangent space multiplied by the scale value provided by the height map. For point B, we should be able to use the same scale value. It's not exactly accurate, but it should be able to get us closer to where point B should be and give us an acceptable result. First thing we need is the observation vector in tangent space. Then we need to find out how much the scale in vertex normal direction is shifted and use that value to modify the UVs. We introduced a custom parameter scalar to add more manual control over the parallax effect. Now we can apply the iris texture with our parallax mapping UVs. By adjusting the value for our custom parameter, that is scalar, we should be able to see the iris being pushed inwards or pulled outwards. You probably also notice that as the scalar value gets higher, the iris texture gets more warped. This is to be expected as we only get the approximate of point B and didn't do any accurate calculation. So keep in mind to keep the scalar value in a small level. Next, we can use part of the iris texture to make the pupil. First, we need a gradient to mask out the pupil. We can get a gradient by using the length of the UV, since UV is a set of coordinates in the range of 0 to 1. What we will get is an evenly distributed black and white gradient. Next, we move this gradient to the center and use one custom scalar to control the overall scale and a secondary scalar to control part of the scale, so we get a secondary gradient. This is very similar to what we did with the UV at the very beginning. And because of the secondary gradient we created with this second custom scalar, we can see part of the UV gets stretched as we adjust the second scalar value. This is how we created the pupil dilating effect. Now that we're done with the iris and the pupil, what is left is the sclera. We can draw the rest of the eyeball with the sclera texture and mix with our iris and pupil texture. The eye is an interesting asset because it can be very prominent in the game, or it can be very insignificant that we don't have to invest more than a simple texture. So what exactly are we aiming to create with the eye? First thing we should take notice is that eyeballs usually have a very strong specular and reflectivity, which makes the character more vibrant and alive. In comparison, when the reflectivity is absent from the eyes, it tends to look less alive and it almost looks like the eyes are painted on. So the key objective to bring more vibrancy to the character is to keep the reflectivity in the eyes strong. There is a couple of ways to achieve this. For example, we can use the reflect function to draw a reflection map on top of the eye. But this seems a little bit too expensive as we are introducing a new HDR map, whilst the eyeball is a relatively small asset compared to the rest of the project. Another way we can tackle this is to create a matte cap material. Matte cap is true to its namesake. It captures the shading quality of the material in one texture, usually a sphere, and render the asset with diffuse, specular, and reflectivity without any complicated calculation. It produces very nice shading results whilst being extremely economic. But there is one shortcoming. The material will always be shaded in the same lighting conditions no matter how we switch the view angle or lightings into scene. Since eyeball is a very small asset, it would be a good fit for matte cap materials. We already know that matte cap materials always shade the asset in the same way without taking into consideration the cameras or the lighting. So we can use the vertex normal data in view space as UV to texture the matte cap texture. Now that the reflectivity is done, there is still something not quite right with the eye. Her face looks very unnatural and her eyes really pop out for some reason. This is because the eyeballs don't have any kind of occlusion with the rest of the face, so they don't really fit in. We can bake an ambient occlusion map to fix this issue, but it is not really feasible for eyeballs because we expect eyeballs to rotate in the eye socket. As a workaround, we can create a new mesh, put it in front of the eyeballs in the eye socket, bake the ambient occlusion onto the new mesh and make it into a transparent texture, and assign the texture to the new mesh. Essentially, we are separating the eye's ambient occlusion in a separate mesh so that no matter how the eyeball rotates, it will always render the occlusion between the eyeball and the eye socket. We can see that now with the ambient occlusion, her eyes looks much more natural and her eyeballs now fits the rest of her face perfectly. This concludes our journey in rendering characters in Cocos Creator. Hope this series has been helpful. Thank you and bye for now.